All right, welcome back. This lecture talks about significant digits, also known as significant figures, and it can be used in order to prepare you for Prelab for Lab 1. It can also be used in conjunction with the printable version of these slides. So if you want something to take notes on, I suggest you get that. You'll want to have a pencil and paper handy so that you can work out a few practice problems as we go through. All right, so in this lecture we are talking about significant figures or significant digits. Now, why do we use sig figs in science? Well, sig figs are important because they tell researchers a little about the instruments that you use to collect data. Sig figs have to do with reporting and using the correct number of decimal places within a particular piece of data. And so they can tell us about how precise your instruments were. For example, here we have two different balances used for measuring mass. And you can see that they measure mass down to different decimal places. The balance on the left only measures down to the 10th place, whereas the balance on the right measures down to the 100th place. So the balance used on the right is more accurate, more precise than the balance on the left. Now, if you were to use the balance on the left to measure the mass of an object, and you reported that mass down to the 100th place, you would be saying that the instrument you used is more precise and more accurate than it actually is, because it can't go down to that decimal place. On the other hand, if you were to use the balance on the right and you were to only report your numbers down to the 10th place, you would be underrepresenting the precision of the balance on the left. Okay. Or of the balance that you're using. So the reason that we need to report sig figs correctly is it tells the researchers how precise, how accurate the instruments are that you used to collect the data. So it's a pretty important skill. All right, so there are three major skills that are involved with sig figs. And the first one is simply recognizing which digits within a number are considered significant. Now remember, when I say significant, I don't mean important. All of the digits within a number are important. But being able to recognize which ones are significant can help you determine which ones you need to write down and record. Okay, so here's rule number one. All non-zero digits are considered significant. So that's pretty easy. For instance, in the number 92, both the 9 and the 2 are considered significant. So that number has 2 sig figs. The difficulty comes in when we're dealing with zeros. So let's consider some situations with zeros, because sometimes they're considered significant and sometimes they are not. Okay, rule number 2. If zeros appear between two non-zero numbers, then they are considered significant. So on the bottom of the page there, 9002 has 4 sig figs. Those zeros are significant. All right, now let's talk about zeros that involve a decimal point. Rule number 3, leading zeros. When zeros appear to the left of non-zero numbers, if they involve a decimal point, we consider them to be leading zeros, and they are not considered significant. Again, it's not that they're not important, it just means that we don't consider them when we're reporting the number. So you can see there that 0.0092 actually only has 2 significant digits. The zeros are not counted. Okay, now let's consider zeros on the other side of the number. Zeros that fall to the right of non-zero digits are referred to as trailing zeros. And trailing zeros are considered significant if it includes a decimal point. So that number on the bottom there, 920.000, we would count all of those digits as being significant because there's a decimal point and because those zeros fall to the right. They're trailing. Okay. Rule number 5 here kind of repeats itself. So I'm going to skip to rule 6 down here. And this has to do with zeros that are trailing, that are to the right of non-zero numbers, but do not have a decimal point in them. For this, it gets a little tricky. We don't necessarily consider zeros that fall to the right without a decimal point significant. So all you can say about a number like 9200 is that it has at least 2 significant digits. And you could say that the 2 zeros that are there are considered indeterminate. So you could refer to those either way. All right. So those are the basic rules for determining how many significant digits a number contains. At this point, I would like you to pause the video and answer the question about these numbers, and then start the video again and we will go over the answers. Okay, so pause it, see what you can do with this information. Okay, hopefully you took some time and worked this out. Here are the correct answers. A, obviously all of the numbers in this figure are non-zeros, so they are all significant. Therefore, it has 4 sig figs. B, these zeros are on the left. They are leading zeros, which are not significant, so only the 2 and the 3 are significant here. C, this zero falls between 2 non-zero numbers, so it is considered significant. So there are 4 sig figs in this number. Going up to D, these zeros on the end are trailing zeros, and there is a decimal point included, so we consider all of them to be significant. So there's 5. E is pretty easy. The zeros fall between 2 non-zero numbers, so they're all significant. There's 6. And F, here we have a 0 on the end of a number, so it's a trailing 0, and there is no decimal point involved in that number. So we can really only say that the first 6 digits are significant, and that 0 on the end would be, we would call it indeterminate. We could say there's at least 6 sig figs there. All right. The next thing that we need to discuss regarding sig figs is what to report when you're measuring things in lab. Different measuring devices have different numbers of digits that it will present you with. So how do you know what to write down? Well, the rules for digital devices are a little different than the rules for analog, non-digital devices. So let's talk about both. Most of the time, you're going to be using digital devices in the lab. And if you measure something on a balance, for instance, and it shows a number on its screen, it's perfectly fine to write down all of the digits that it presents you with. Okay, so that's easy. It pops up a number, you write it down, you're done. Now, things are a little trickier on analog devices. For instance, if you're using a ruler, as is shown at the bottom of the screen here, you have to decide how many decimal places you're going to write down to. And the rule for this type of device is that you want to write down to the first estimated decimal place. So what do I mean by that? Well, using this ruler, we're measuring this object, whatever this is. And you can see that this object extends all the way to 6.1, 2, 3, 4, 5, and it extends a little bit past 6.5. So the 0.5, that you can see, that's not an estimation. You can clearly see that it goes at least to the 10th place. However, since it falls between 0.5 and 0.6, you're going to need to estimate to the 100th place. So for instance, maybe you think that that object extends to 6.57 centimeters, almost over to the 0.6. Since it extends beyond there and the first estimated digit would be the 100th place, you need to report down to the 100th place. That's the correct way to report that. All right. Next, you'll find yourself doing addition and subtraction problems in certain situations. Not all of the numbers will have the same number of significant figures, and so you need to understand how to report your answers with the correct number of significant figures. So what are the rules for addition and subtraction? Well, basically, what you want to do is you want to find the number in your problem that is the least precise. In other words, it has the smallest number of decimal places to the right of the decimal point. So if you're looking at this math problem here on the bottom, you can see pretty quickly that 5.5 only goes down to the 10th place. So it's the least precise compared to the other two. The least precise number in the problem is going to set the standard for what you report. And with addition and subtraction, as it says here, you want to match your answer to the same number of decimal places to the right of the decimal point. I should say point on the end there. All right, so this goes down to the 10th place. That means that the answer you report is going to have one digit in the 10th place. In this case, if you put these numbers in your calculator, it's going to spit out something like this, 16.848. So what you will want to report is 16.8. Okay. Now, if that 4 had been a 5 or higher, you would need to round up and report 16.9. But because it's a 4, it's okay to leave it 16.8. Okay, so you match it to the same number of decimal places as are to the right of the decimal point. At this point, I'd like to have you pause again. Try to work these problems out and report the correct number of sig figs, and then you can check yourself when you're done. Okay, so pause the video now. Okay, hopefully you were able to work those out. Let's take a look at the answers here. All right, if you put these numbers in your calculator, it's going to crank out a nice long answer for you. So what do you report? Well, if you look closely here, you're going to notice that this middle number, 135.02, is the least precise because it only goes down to the hundredths place. That means your answer is going to go down to the hundredths place. So you might report 169.04. Okay. On this bottom problem, the least precise number is this 5. It doesn't go down to the 10th place, or it doesn't go down below the ones place. So your answer is only going to go to the ones place. So you would report it as 3. All right. Now there's also a rule for multiplication and division, and it's a little bit different than the rule for addition and subtraction. So how does this work? Well, again, when you're multiplying or dividing a long series of numbers, you're going to look at the numbers and you're going to find the least precise number in the series. So in this case, it would be 5.2. Now it's going to set the standard for your answer in terms of how many places you report. But unlike addition and subtraction, you're going to look at the total number of sig figs involved in this least precise number. And you're going to match the total number of sig figs to this number. Okay, so it doesn't matter where the decimal place falls in this case, but since this number has 2 sig figs, your answer is only going to have 2 sig figs. Okay, now let's look at this problem. If you type this problem into your calculator, it's going to crank out this big nasty number here, 164.126, blah, blah, blah. So how do you put this in a form where you only are reporting 2 sig figs? Okay, well, in this case, you're going to have to use scientific notation. Okay? You can't just put down plain old 1.6 because the quantity here is 164. And there's a big difference between 164 and 1.6. But if you use scientific notation, it'll work out. So here's how you would report the answer. You could say 1.6 times 10 to the 2, and then your unit here is millimeters cubed in this case. Okay, so now you're only reporting 2 sig figs, and it matches. So the total number of sig figs is going to match, not just what's to the right of the decimal point. Okay. Time again to pause the video and try these problems on your own. And of course, you can check your answers in just a moment. Okay, here we are again. Let's take a look at these answers. In the first problem, the number that is least precise is here, 3.4. It contains 2 sig figs, so you're only going to report 2 sig figs. So you would report your answer as 5.3. Down here, this number, 1.4, has 2 sig figs, so you're going to report 2 sig figs. And in this case, you're going to round your number to 33, because there's 2 sig figs there. Again, it doesn't matter where the decimal point falls, as long as the number of sig figs matches. Oops. Okay. One more note I would make about working with significant figures has to do with rounding. It is okay to round your numbers up or down, depending on the case. But what I would suggest is that if you're doing a series of calculations, don't round anything. Don't worry about the sig figs until the very end of all the calculations. That's when you want to do your rounding. If you round your numbers at the beginning of a series of calculations, it's going to throw off the rest of it mathematically. You're going to end up with different numbers. So round at the very end and then report your significant figures. Okay. Sig figs can be a little troublesome. They take a bit of practice to get used to. So what I suggest that you do now is you can go into your Prelab for Lab 1, and now you can read through it and complete Part C, which is page 3 of your Prelab. Now, if you want any more information or you're still having trouble with significant figures, you can, of course, contact me via email or in class. Or you can visit the Useful Links folder on Blackboard, and you're going to find a significant figures folder in there that has videos and other tutorials and more practice in there for you. So if you're having trouble with this subject, visit that folder and check it out. Okay. Thank you for joining me, and I will see you guys in class.